Okay, so a significance test makes a type 2 error when it fails to reject a null hypothesis that really is false, but it is more common to report the probability that a significance test does reject H naught when an alternative parameter is true. So there is a specific term for that in stats, and it is called power. So power refers the power of a test against a specific alternative is the probability the test will reject H naught at a chosen significance level alpha when the specified alternative value of the parameter is true. So I like to think of power like this. Power is the probability we correctly reject the null hypothesis. And so I have a little diagram that I want to show you that shows the relationship between alpha, beta, and power. So let me draw that real quickly. Let's say that this density curve here represents the null hypothesis. And that this density curve represents the alternative. Okay, there's some point out here. Okay, we're gonna set this line at the Z critical value. Right? So let me change colors here. Just a second. So on this side of the line, we are going to fail to reject H naught. Okay, because my null hypothesis is over here. And on this side, I'm going to reject H naught in favor of the alternative. So let me scroll up just a little bit. This part right here. If I reject H naught, okay, so I'm on the right side of this dotted line, but I'm still under the null hypothesis, okay? What is that? I reject H naught, but H naught really is true. So that would be type 1 error. And what is the probability of that? That is alpha. Okay. Well, let me change colors here. If I'm on the left side of the dotted line there, okay, I'm going to fail to reject H naught. However, I'm still under the curve of the alternative hypothesis. Okay, and so this green section would be a type 2 error. And the probability of that is called beta. Alpha and beta are the first two letters of the Greek alphabet. Okay. Well, everything over here on the right side that's not under that curve, that is power. This power is this area, okay? It's the probability that we correctly reject the null hypothesis. All right, so let me make a few notes here. Okay, alpha means we reject a true hypothesis. That's a type 1 error. Beta means we fail to reject a false hypothesis. Which is type 2 error. And so power, another way to state power would be, it is the probability we avoid a type 1 error. No, I'm sorry, the type 2 error. It's the probability that we avoid a type 2 error. Okay, so it's important to note, so look up here for a second. All right, that alpha and beta are inverses of each other. Okay, so if I take this line, the rejection line there, and I move it this way to the left, what happens to beta? Beta gets less, right? And what happens to alpha? Alpha would get larger, right? What happens to power? Also, if I take this line, the rejection line, the z critical value, and move it to the left, power would get larger also. And vice versa. If I move it this way, beta is going to be higher, alpha would be less, and power would also be less. Okay, well, the power of a test against any alternative is 1 minus the probability of my making a type 2 error for that alternative. So power is equal to 1 minus beta. Okay, why is that? What is the area under the density curve? Has to be 1, right? And so power, everything that's left in here, if I take 1 minus beta, that's going to leave me power. But you need to know this. It says, how can we increase the power of a significance test to detect when H naught is false and the alternative is true? Okay, 2 main ways. I'm gonna eliminate that one. I don't really want to go over that. But there are 2 main ways. Number 1, we increase the sample size. Or number 2, we increase the significance level. Okay, so for example, if I increase alpha, that would mean this line, the z critical value line, would move to the left to make the red portion there greater, right? And what would happen to power? Well, beta would decrease, therefore power would increase there. So we can either increase the significance level or we increase the sample size, which would make the result less variable and most likely give us better data. Okay. Any questions on that?